Alright, I had a request here for some calculating present value of bonds. And I've got a couple tables here, which I'll expand in a few minutes. This might get a little messy, but we'll try and keep it as neat as we can. But I'm going to show these through the expression or equation that we may have for calculating these, and also how we use the table. So, first thing we have here, number one, says determine the present value of 10-year bonds payable with a face value of $86,000 and stated interest rate of 14% paid semi-annually. The market rate of interest is 14% at issuance. Well, in this case, when we look at the bonds and we're calculating, when the interest rate on the bond and the market rate is the same, the present value of the bond, or the issue price of it, will be the same as the present value. So for number one, this is a pretty simple one. We're looking at $86,000 because the interest rate of the bond is equal to the market rate. Okay? Now, the second part is where we have to get into calculations here. And in number two, what it states is we have the same bond payable. So essentially we're looking at 14% on the bond. It's a 10-year bond paid semi-annually. But this time the market interest rate is 16%. Now, when we go to calculate bonds, if we're going to use a equation, then the equation we use is the present value is equal to, and this is of a lump sum. This would be the present value of 1. The present value is equal to the future value divided by 1 plus the interest rate per period to the n power, and n in this case is the number of periods that we have. Now, thinking about this, and before we go any further, one thing I do want to explain is when we are calculating these, we really want to concentrate on using the market rate. So, our market rate is 16%. Now, given that we're paying the interest on these bonds semi-annually, that's twice per year. So our rate per period is going to be that market rate of 16% divided by 2, because if we're paying semi-annually, we're paying twice per year. If this were to be quarterly, then our denominator here would be 4. If this were to be monthly, our denominator would be 12. So our rate per period in this case is equal to 8%. Now the number of periods that we see, well, we're looking at a 10-year bond, and paying semi-annually is twice per year. So 10 years, 2 times per year, means we have 20 periods. So, looking at this, if we're going to use this present value of 1, that's what we'll use. And I want to write this down somehow. When we're calculating bonds, there are 2 things we need to calculate. Number 1 is the present value of the face value of the bond. That's the first thing we have to calculate. And the second thing we have to calculate is the present value of the interest payments that bond will be paying. So the present value of interest payments. These are the 2 things that we need to calculate. And when we're calculating for the bond, this is, of course, as I said, but I'll make note of it, this is present value of $1, or sometimes you might see it as a lump sum. Okay? So given this equation, we know the present value of this bond will be equal to the future value. In this case, we could also say the face value of the bond, because that's what we have to pay once this bond matures, divided by 1 plus the interest rate per period to the n periods power. So to set this up, we're essentially going to say the present value of this bond is equal to, well, we know the future value is $86,000. So it's equal to 86,000 over 1 plus R. Well, our rate is 8%, which decimal equivalent is 0.08. So we'll have 1.08. And in N, we have 20 periods. So if we want to use an equation to do this, we're going to just essentially take 86,000, divide it by 1.08 to the 20th power. So if we do that, 86 divided by 1.08 to the 20th power, we get $18,451.15. So this is the present value of the face value of the bond. Okay, so that's the first part of this problem that we need to do. And I'm going to try and see what we have here, what we can do with this table. If we're using a table in this case, and this is the present value of one table, remember we're looking at 8% and 20 periods. I'm going to make this table a little bigger here, and if we look where we have 8% is here, and if we go down to 20 periods, we will see a factor here of 0.2145. If we multiply that 0.2145 by the 86,000, which is the future value or face value of those bonds, we'll get $18,447. We have a difference here because of a rounding error. Whenever we use a table, we will see a rounding error. So let's see, that's 0.2145. I'm going to close this, delete this table, 0.2145. So the other way we can do this, if we use the table, is to say 80, whoa, we don't want that. We want this. The other way we could do this would be to say, and I'll put it here in the table space, 86,000 multiplied by 0.2145. And what that gives us is 18,447. As I said, when you use a table, you'll get not an exact amount because of rounding errors. The table, if we look at it, 1.08 to the 20th power, whoa, I don't know what that was, but we're going to get rid of that now. And get back in the realm of control here. If we're looking at this, that 1.08 to the 20th power is actually equal to 4.660957,144. So how we're looking at this, how we get to this decimal of 0.215, if we were to take, and let me type this out here, if we were to divide 1 by this number, we get 0.214548274. So really, we do have a rounding error here. If we're using the table or the equation, that we need to divide our present value or future value by this point, which is why we have it in this manner. So that's just a little difference between if we use the table versus if we use an equation. Now, we got the present value of the face value of the bond, which is this part. The second thing we need to find is the present value of interest payments. Okay. Now, for that, we need to use the present value of an ordinary annuity. And in this case, when we look at this, the present value of an ordinary annuity is equal to 1 minus 1 over 1 plus r to the n. And this whole thing is over our interest rate. And again, we've already calculated rate. We've already calculated our number of periods. So this is the present value of 1, and we will look at this as present value of ordinary annuity. Well, in this case, we know what the equation is, but here with an annuity, these are equal payments. That's essentially what annuity means. It means equal payments over a period of time, or equal payments over equal periods of time. Now, in the case where we use the present value of an ordinary annuity, what we have to do in this case is we have to find the interest payment. And that's the interest payment per period. So if you'll remember, when we looked up here, the bond paid 14 or pays 14% interest. Okay? Well, 14% interest semi-annually would be 7% per period. And this is the point where we use the interest on the bond. For everything else, we use the market rate. But to calculate how much interest the bond pays, we use the interest on the bond. So if we're looking at 7%, basically what we have to do here is we're going to take the 86,000, which is the face value of the bond, and multiply that by the interest that the bond pays per period, which is the 7%. Remember, that's this 14% divided by 2, since it's paid semi-annually. If it were paid quarterly, it would be divided by 4. If it were monthly, it would be divided by 12. So 86,000 multiplied by 0.07 means we are paying $6,020 in interest every 6 months on this bond. So what we've got to do here is we've got to say, okay, we're looking at $6,020. That's our interest payment per period. And what we're going to do is multiply that by our equation here. And I want to erase this first. We want to calculate our equation. The first thing we want to do. So if we put the numbers in here, we get 1 minus 1 over, and remember, 1 plus our rate, we're using market rate. That's 1.08, and we have 20 periods. And this whole thing is over our rate per period, which we know is 0.08. So this can be a little tricky to do on a calculator because there's a lot here. But if we say 1 minus, and we use our parentheses, 1 divided by 1.08 to the 20th, in close parentheses, what we'll get is 0.7854517926, which I'll write this out here. Oh, I'm having some issues today with this. Okay, back to it. We're essentially looking at, what is this, 0.7854517926 over 0.08, and when we divide that, we get 9.81814 7407. What we do is we take this factor, we multiply it by our 6,000, our interest per period that we're paying. So when we look at this, we will have $6,020. We're going to multiply that by our 9.818147,407, and what we'll get is $59,105.25. Okay, this is the present value of the interest payments of the bond. Okay. So we have two numbers here that we've calculated. We have the present value of the face value of the bond, and we have the present value of the interest payments of the bond. Now, if we add these together, 18,451.15 plus 59,105.25, what we will get is 18,451.15, $77,556.40. This is the present value of the bond. If we were to sell that bond today, given the information that we have here, 10-year bond payable with a face value of $86,000, stated interest rate of $14,000, paid semi-annually, and the market rate being 16%, we have $77,556.40 in the bonds. Now, let me pull up this future value of annuity table so we can see what we have here when we look at this through 20 periods at an interest rate of 8%. So an 8% rate in 20 periods, we get 9.8181. And remember, what we found here was 9.818147407. So we will have a rounding error if we use the table, because we'll be leaving out this 0.000047407 value. So tables are nice to use, and they make things easier for us, but you've always got to remember that a table is not going to give you an exact value. Okay, now the last part of this problem says what we want to do is we have the same bonds payable. And another thing we can think about in this case, another thing that we can think about an issue with this is when we look at this and we see this, we should know that given that we have the market rate of 16% and the bond at 14%, this bond should be paying at a discount. And that means that when we're paying a bond at a discount, we're looking at an instance where the bond issue price or the present value is less than what the face value is. And that's why we come up with $77,556.40 here. Now, let's look at part 3 of this. Now the market interest rate is 12%. Now when we're at 12%, the market rate is 12, the bond rate is 14. The bond's having a higher interest rate than the market. In a case like that, this bond should be issued at a premium. So we'll come down here a bit. We'll get all this stuff out of the way. And we will look at number 3. So for number 3, remember again, we want to find the present value of the face value of the bond. And to do that, if you remember, we're looking at present value is equal to future value over 1 plus r to the n. Now in this case, remember the market rate is 12%. So at a 12% market rate, let me write that here, market rate is 12%. At a market rate of 12%, and this is still semi-annual, our period rate is going to be that divided by 2. So we're looking at 6% per period. And we still have 20 periods. That's not going to change. So when we want to look at the present value of this bond, and I'm going to use the formula here that we have. We have the future value or the face value of the bond of 86,000 divided by 1 plus our market rate of 6% per period, which is 0.06 to the 20th power, which means we're going to have 86,000 divided by 1.06 to the 20th power. And if we calculate this out, 86,000 divided by 1.06 to the 20th, what we will get here is $26,815.21. Now, that's the present value of the face value of the bond. And since we have a lot of things, when we work these out, we get a lot of drawing, as you can see here. And whiteboard's not helping me out too much tonight, but usually you can circle this or make a note somewhere so you don't lose this in all your writing. Now, that's part one. The second part is to calculate the present value, and we'll put it here, present value of the interest payments. So the present value of the interest payments, if you'll remember from just a minute ago, that was 1 minus 1 over 1 plus r to the n. This whole thing is over our rate. So we're going to use this formula to calculate. And remember, we need to know the interest payments of the bond. And if you'll remember, that was $6,020. That's our interest payment per bond. We calculated that earlier. These are our interest payment amounts. So, to figure this, what we're going to do is once we figure this using our 6% and 20 periods, we will multiply it by our interest payments to get the present value of that amount. So looking at this, we will essentially have 1 minus 1 over 1.06 to the 20th, and this whole thing is over 0.06. So if we do the first part of this, 1 minus, use our parentheses, 1 divided by 1.06, that should be a 20, to the 20th, we will get 0.688,195,2731. If we divide that by 0.06, we get 11.46992122. And all we have to do now is multiply that by our $6,020. And what we'll get is $69,048.93. So this is the present value of interest payments. Now we've got these two items, this 26,000 and this 69,000. We need to add those together. We add those together, the 26,815.21 plus the 69,048.93. Let's see, 26,815.21 plus 69,048.93 gives us $95,864.14. This is the present value of the bond for number 3. And remember, in this case, the bond rate was 14%, I believe. Yeah, the bond rate was 14%, and the market rate was 12%. So in this case, the bond paying a higher rate than the market, this should be issued at a premium or a price higher than the face value of the bond. And we scroll back up, remember, the bond was 86,000. So this makes sense for us to have it this way. So as I said, this got a little bit messy. Whiteboard didn't want to play well, but hopefully this helps with calculating the present value of bonds when we have to use either a table where we get a figure, or when we have to use the formula or formulas that we had here at the top. The present value of one, and then the present value of an ordinary annuity. So if there's any questions, post them in a comment here. If you're in one of my classes, leave it on the discussion board, or you can call, text, or email. And other than that, stay safe and enjoy your accounting.